So today's lesson is going to be over matrix operations. This is the next section in our systems of equations chapter. Now, up until this point, we have covered solving systems by substitution, elimination, and graphing. And there's actually another way that you haven't seen up until this point, and that is matrices. Now, in order for us to be able to use the matrices to be able to solve with them, we kind of have to know what a matrix is and kind of some basic things that we can do with them. And so that is what we're going to be working on today. It's just kind of looking at what a matrix is and some of the different things that we can do with them. And so first off, we're going to look at just some definitions on what it means to be a matrix. So a matrix is going to be a rectangular array of variables or constants placed in rows and columns. Now, an element of a matrix is going to be any value in a matrix. And then the dimensions of a matrix are going to be m number of rows by n number of columns. So basically, we're going to use this to describe how big a matrix is. And so we would say that it's an m by n matrix. So it kind of looks like a multiplication symbol, but it actually stands for number of rows by number of columns. Now we're going to look at kind of what this stuff all means, because right now it's not making a lot of sense. So here is 4 examples of what a matrix can look like. So usually we have a square grouping symbol around it, and then we have our elements, which in this case are all numbers, inside. And this question asks us to state the dimensions of each matrix. So remember that rows go across, columns come up and down. So on this one, we only have 1 row, but we have 3 columns. So we need to write that we have a 1 by 3 matrix. So we put 1, we put our little X, which stands for by, and then we have a 3. So we have a 1 by 3 matrix. So then in our next example, this time we have 2 rows, but we still have 3 columns. So this would be a 2 by 3 matrix. Coming to our next one, it's a little bit bigger. It's actually a 3 row by 4 columns. So this would be a 3 by 4. And then lastly, notice on this last one, we have 2 rows and 2 columns. And this is actually a special matrix because its number of rows are equal to its number of columns, which means that it is a square matrix. And square matrices are nice because they have some special properties. However, we can deal with matrices of any shape or size. All right, so let's look up at a little bit more. So we can do some basic operations with our matrices. We can add them, and we can also subtract them. So the easiest way for me to show you what you're going to do is just kind of give you a basic example. So if I had a 2 by 2, let's call it A, B, C, D. So my variables this time are my elements instead of my numbers. And I wanted to add that to another matrix. And let's call it E, F, G, H. Super original, I know. Now, in order to add those two matrices, I'm going to get a resulting matrix, which is going to be the same size as the two that I was adding together. So I have A plus E, and that's going to go in the same spot that those two variables are in. Then going across, I have B plus F. And that goes in the same spots that those were in. And then kind of continuing that same pattern, I'm just adding the corresponding elements from each matrix. So it's pretty straightforward. Likewise, if I wanted to do subtraction, it's going to be very similar. The only difference is instead of adding each of my elements, I'm going to subtract each of my elements. So I would have A minus E, B minus F, C minus D. Sorry, C minus G. That needs to be corrected up there as well. So C minus G, and C, change this to a G now as well. There we go, that looks better. C minus G, and then D minus H. So that's kind of the general format. So let's look at an example with adding or subtracting. So here it tells us that we're going to find A plus B. So I'm going to take my matrix A, which is 16, 2, -9, 8. I'm going to add that to -4, -1, -3, -7. Again, adding my corresponding parts. I'm going to go ahead and write out the steps just so we can all see where each of the things is coming from. So I have 16 plus a -4, which is the same thing as 16 minus 4, which is going to give me 12. Then I have 2 plus a -1, which is the same thing as 2 minus 1, which gives me 1. Then I have a -3 plus a -9, which is also going to give me a 12, but this time it's a -12. And then we have 8 minus 7, which also gives us 1. So our resulting matrix would be 12, 1, -12, 1. All right, next up, we want to do some subtraction. Now remember that we said that we can do this the same way that we did our other one. We're just going to subtract the corresponding parts. However, be careful because notice if I were to start trying to do this, I would have 8 minus 5. So far, so good. Then I have -3 minus 1. Well, then I still have a -4 and a 2 in my second one, and I don't have anything in my first one. So what do we do? Well, we're actually not allowed to do it. And the reasoning behind that is because we have to have elements that match up for every single spot. So if we have something that doesn't match up, so in this case, the dimensions don't match up, we would just say that this is impossible. So our dimensions don't necessarily have to be square. We could have a 2 by 3 minus a 2 by 3, and that's going to work. However, in this case, we have a 3 by 2 minus a 2 by 4, and we just can't do those. So looking at our next example, and we can also multiply. We may have seen the term scalar before. If we haven't, that's all right. Basically, what a scalar means is it's just going to be a single number. So for scalar multiplication, I'm multiplying a matrix by a scalar or constant. So we could look something like this. We're going to have our constant k out to the front. And again, we have A, B, C, and D. And we can kind of think about it like distributing. We're going to take that constant and apply it to all of the elements on the inside. So we would have Ka, Kb, Kc, and Kd. So looking at an example of that, so it says if r equals -12, 8, 6, -16, 4, 19, find 5r. Now it's pretty general notation that in order to represent a matrix, we're going to use a capitalized letter. So in this case, we label it r. So I'm looking at 5r. So I'm going to take my scalar, which in this case is 5, and we need to multiply that to the matrix that they gave us as R. And again, we're basically thinking about kind of like it is distributing. So we would have 5 times -12, 5 times 8, 5 times 6, 5 times -16, 5 times 4, and 5 times 19. And then we're just going to simplify that. Again, you don't have to write out that middle step. I'm just showing you so you can see where I'm getting all of the numbers from. So we have 5 times 12, which gives us -60. 5 times 8, which gives us 40. 5 times 6, which gives us 30. Going down, we have 5 times a -16, which is going to give us -80. 5 times 4, which is going to give us 20. And then 5 times 19, which gives us 95. And so that would be my resulting matrix. So again, these are going to be just some of our basic matrix operations. In our next lesson, we're going to look at the last operation that we have, which is going to be multiplication.